Hello and welcome back to compiler programming. Today I want to work on something that is not directly in the compiler, but something that will be used by the compiler, and that is the buffer implementation. So right now in my sort of the standard library that I wrote for myself, I have two types of buffers, and the first one is a fixed buffer, and that's exactly what it sounds like. We have a fixed chunk of memory that we can arbitrarily address, and that we can write to and read from. But if we run out of that memory, if we need something bigger, we either have to reallocate the whole thing, moving somewhere else in memory potentially, or we will get an error if we try to put there more than we could. Another type of buffer that I have is a bucket buffer. This one is not contiguous in memory, so it has buckets. They are either page-sized, or if you try to allocate something that is larger than memory page, you will get that larger size. It is growable, so the problem with bucket buffer, it has a slightly larger overhead than the fixed one, and also it is non-contiguous in memory, which is a no-go for certain kinds of things, which are especially going to be important when we will start doing JIT. In general, it's just not as convenient to work with. So ideally, we would like to have something that is the best of both worlds. We want to have a resizable and contiguous buffer that is not technically possible to full extent, but we can make something like that with virtual memory, because when we have a 64-bit operating system, we have a lot of virtual memory. Like each process gets a tremendous amount of virtual space that would potentially be part of their memory. I think on Windows that is 256 terabytes that you can address from the process, something like that. And that is plenty much, especially for the purposes of what I'm trying to do. Even if I'm not actually going to be using all of that memory, I'm going to be fine. So the idea that of how this works is that you ask the operating system to give you a range in memory. You will, for example, say, I want to get 1 gigabyte of memory. But you don't actually give me any physical memory. You don't even give me anything. Like this call basically just says that numbers from, I don't know, from 1 gigabyte to 2 gigabyte are now reserved for me. I literally just get these range. I don't get anything physical out of it. The only thing I get is a guarantee from the operating system that if someone else or myself in another time ask for the memory, that asked memory will not be in that range. And then I can do a separate call to say, okay, now I want to actually get some memory from that range. And this is what we'll try to do, because that essentially allows us to pre-allocate very big buffers. They will get a lot of virtual address space, but they will not actually take that space in reality. So if you will look into your program manager and try to see the memory consumption, it will not be there, but it is just something that is convenient for us to do. So let's get going. We will call it virtual memory buffer. Okay, here let's just do, it should be able to initialize, nothing really fancy. We'll just say that this would be the type of it. Buffer, actually I will locate it right on the stack. Don't even need to initialize it, because the next call will be virtual memory buffer init, and it will get the buffer, and it should get the capacity, and the capacity is the first thing that is going to be quite interesting. So this deals directly with virtual memory. That means that I cannot, like, even if I ask for a smaller buffer, I will get the buffer that is at least the size of the page, and actually it will be at least the size of the minimum allocation, I think. So this might even have already something to get that information, maybe. This is performance counter, system allocator. I don't remember if I actually get that information just yet. I guess I do not. So I only get the number of processors here, but there is a way to basically get the minimum size that you will get. I think it's 65K on Windows, but no matter. Okay. So essentially this number here will be not what you will get, but what you will get, at least it will be rounded to 65 or 64 kilobytes, 65,000 bytes. Okay, init, and then I guess I should be able to append some stuff in there. That seems reasonable. Append buffer, and what else? Another thing that is going to be different about this buffer versus the regular one is about writing. Like, you always have to write through a function. You cannot write directly by like getting a pointer somewhere to somewhere inside of this buffer and doing some funky stuff. You have to always use the sort of getter and setter functions, because those functions will need to make sure that you have sort of that range is committed correctly into the system. Okay. Virtual memory and S8, and I guess it's okay to read. If you are sure, you will get a panic if you try to read that it's something that is not allocated. So maybe that's actually okay. It is better behavior than you get with regular memory anyway. So we will do then check that buffer memory 0 is 0xAA. And then we will deinitialize this. Okay, obviously we don't have the implementation. So let's go here and start working on it, starting from a fixed buffer. Okay, virtual memory buffer, it's fine. Type def struct. Okay. We also want to track occupied, of course, and we want to track memory, but it will be a pointer and not directly after the array like it was in fixed buffer. Okay, let's do void virtual memory buffer init. You get the buffer, and you also get a capacity that we want to allocate. So something like this, minimum capacity. Right. Okay. Dneat buffer. Okay, yeah, I'm only gonna worry about Windows right now, and I will not go into this if-def madness that we'll have to do to support also Linux and Mac. So for now, we'll just focus on the Windows part of this stuff. How that will look like? Well, we'll say that virtual alloc. Yeah, I need to figure out what is the size that we will need. System info. Yeah, DW allocation granularity. This is what I'm interested in. Let's just verify that we don't have it here. No, we don't. Okay, so I will need that then here. Static pin 32 allocation granularity. Yeah, something like that. Forgot the type. U64. And let's get it in get system info. Right. So it is sort of similar to this thing. So maybe I will just do it like so. Well, let's Google how it is on Linux. Linux get memory mmap granularity or something. Alignment and granularity. What do you say? SC page size. So it looks like it is still SC page sized. Okay. Fine. Then this is the same for both of them. That's okay. And here we will get then something like this. Actually, I can, yeah, it is the same as here. If size is -1, then we get the granularity here. NTV allocation granularity. Right. That seems reasonable. That's not page size, that's memory allocation granularity. Cool. Right. So here now we will need to say U64 granularity. Granularity is S32 to U64 of whatever this returns to us. And now I will say U64, and capacity is going to be basically the maximum of those two. Actually, I need to set the maximum. It's actually alignment. U64 a line of minimum capacity to granularity, something like that. And then we'll say, actually, we can do buffer capacity right away. We can say, no, I want to do it that way. Buffer is virtual memory buffer. Capacity is capacity. Occupied is 0, and memory is so I will do void star memory is virtual alloc, and I can look into how I already do this. Right. So let's copy these two. Sounds reasonable. And the trick, what I was talking about here, is that in regular allocation we reserve and commit in one go, but here we will just do reserve. Right. Okay, and I'm not even sure we need to provide page read write in here, but we will. That's fine. And here we will just release. I wonder if I can release the whole range. I think I can, but we'll see. So buffer capacity, I think I need to do something like that. I don't know if it's gonna work, but we'll see. We'll figure it out. Okay. What else? That should do it, I think. Virtual free pointer mismatch for actual parameter. Yeah, you want the memory here, not the capacity. Okay. Yeah, you don't take an extra parameter. And here we have append, right? So we need to have fixed buffer allocate bytes as the main thing. This is not fixed buffer, of course, it is virtual memory buffer. Allocate bytes, you get byte size, you get alignment. That's good. The tricky part is to figure out what is like when do I need to commit the pages. I can make it slightly differently. I can just set up a fault handler for specific range, I think. So whenever I try to access something that is not been allocated, the Windows will call me back and tell me that, oh, actually you're not allowed to do that. But I think I will try to do something else first, and then we will see if it will actually work, and if it does, it might be a simpler version of this. So, right, and we get the capacity, we allocate, blah, blah, blah. We assert that buffer capacity is more than allocated, great. And we update occupied, that seems reasonable. And this is our result. We update occupied with byte size. we don't have last allocation. And what we are going to do now here is we are gonna actually call virtual alloc again. And we will do it. So I have no idea if this is gonna be terrible performance, to be honest. That's something I will need to measure. But right now I'm more interested in if whether it works at all. And the idea here is that I will say that buffer memory. I don't think I need to even assign it to anything. I will just provide the address here, and then I will provide the occupied, and I will say mem commit. I think that's how it's supposed to go. So I'm saying that this chunk of memory from wherever it was allocated to buffer occupied, I can sort of round it up maybe for the page size. So S32 page size is memory page size. And I can say, actually you can do U64 and S32 to U64 here. And here I will also align like so. Right. Well, that builds, but now I also need to get these things in, which are just helpers that I have for different sizes. Actually want this to do here, and I'm not sure I want it inline, to be honest. That's quite already a chunky function. So let's see. Okay. Need to change fixed to virtual everywhere here. And go from there. Right, and also the type. I don't want the resizing one. That seems good. Align of. Okay. Yeah, something like that. Do you build? Fixed buffer, no. I forgot to update it here. Great. So that builds. Let's see if that runs. No, it does not. Why not? I guess let's see what we have here. 32, RGBAC. Okay. So remedy VG and then prelude spec RGBAC. So let's see what's going on. And I want to break at virtual memory. Let's break in here. Okay. What's going on? Let's see. We get locals, actually params, buffer, That's not very nice. Wait. Okay, let's restart. Do we get memory? Right, memory is right now not accessible because we have not committed it. That's fine, that's okay. But we get here, and we get into append, and get inside, and what is aligned occupied? Okay, it's 0, it's not, alignment is 1. Okay, we assert that we have the space, we update occupied. It's very weird that it cannot read this stuff. Like, why is that? I mean, that's perfectly a valid object. That's strange. Buffer occupied. What if I do explicitly? Unable to find type. Okay. Like, do you need me to rebuild it? Is that the problem? No, it's just has no idea what the type of this is. Okay, that's not great. Let's then do build slash prelude spec. Let's get Visual Studio. Maybe it will have better luck with all of this. Okay, you can run, but you don't know where to get the source code for this. So let's get the source code, right? And here we will say virtual memory init allocate bytes, right? Let's try to run. Okay. Can you read what the buffer is? Yes, you can. We cannot read the memory, but that's sort of expected. Right? So this allocates the bytes and then it tries to assign them. Fine. Let's look at our buffer. So our page size is 496. Yeah, that's what I expect. And then we try to commit this range. Maybe I'm doing it wrong. The question is it now readable? Well, yeah, that actually is now readable. So why does the test fail then? This is the question. Memory minus 86. It's AA. Right. What? I'm very confused. Virtual memory buffer. I mean, it is AA at that address. So, huh? So let's do something like S8 actual is this, and S8 expected is this, and I can even do it to be sure. Actual is expected. Right. Let's try again. So actual and expected are the same. Now it works. I don't know what was the problem, to be honest. Not sure I really care much, maybe. I don't know. But this seems fine. We can look at the process memory here. So memory usage, enable snapshots. Right. But process memory is what I'm interested in. And we are barely getting any memory. And actually, now let's restart this and see what is our memory usage when we have not cleaned it up yet. So it's just, yeah, right now there is basically no memory usage because we, yeah, that's what I wanted to see. Great. Cool. So that works. This is basically what I was aiming for. And I guess it makes sense to add a few more methods, maybe. Let me quickly look at what we have. So there is appending a slice, but we can actually make that happen, maybe. Buffer 0, that's zeros. We don't need this method really because when we create the buffer from system, it automatically zeros memory for us, so there is nothing really interesting there. I guess I can make these two methods available and append slice. Okay, so let's make these two available. Virtual memory, virtual buffer, right? And that's that. And I also want to have append slice. There is also fixed buffer slice. I'm not sure I will need that one. Right, let's just keep it as minimal as we can, and then we'll go from there. Virtual memory, buffer slice, right? Okay, those are the methods. I guess since it worked out pretty straightforward right now, let's see. One more test I want to do is I want to actually force more page faults. So where's my virtual memory? Yeah. So here it should initialize and append byte. Should be able to expand committed storage. So what I will do is I will allocate a megabyte, and then I will write out that megabyte. This also should give us some indication over whether we can optimize it slightly, because calling system functions is generally not a great idea for performance. But anyway, so 1 megabyte. Let's say that's going to be capacity. Is this? We want that size. It's less than capacity. We do plus plus, and we will do append u8 u8 of I percent percent 255. So this would produce a very regular memory pattern, which we can look at and see if everything is correct. Okay. And then we can go over and verify that it works. Something like that. Okay, let's try to run tests on this thing and see if it's any better. That does not look promising. Actually, the test succeeded, but it was ridiculously slow. Writing a megabyte of memory should not be that slow, so yeah. I assume the problem comes from this thing, because for every byte we are calling virtual alloc, and that is not great at all. So we have occupied, but we also need to have committed. And I think I will actually commit also in no, let's do page size commit. That's fine. How would that work? Basically, we have occupied, right? Then we have page size. Then we have 64 required to commit is this, and if required to commit is more than buffer committed, then we do the commit. And we could even simplify stuff here. For now, let's make this version work, and then I will try to optimize it even further. Required to commit, and then we say buffer committed is required to commit. Is it with 2 T's? English is not my native language, so yes, it is with 2 T's. It's committed. And then we say committed is 0. And basically occupied is how much we written to, and committed is how much is available to us. Technically, we don't really need all of them to be U64s, but that's just fine. Okay, so buffer committed looks good. Let's try to run that again and see. Okay, no. Wait. Yeah, Visual Studio is holding off the directory. Yeah, but that's much, much better. So now we actually only do it once for every page, so 4096 times less than we did before, which is great. Can we make it even better? I guess we can. What we can do is we can start with you can say void star commit start is this. So since we already said that the previous memory is committed, we can only ask to commit what's afterwards. I'm actually not sure if it's going to be faster or slower. I probably should measure that. Well, yeah. Let's measure that before we go any further. So how would I do that? I think I have here performance counter. Yeah. So I can do something like that. Performance counter, right, right, right. I don't exactly remember what to do with it though. What does end give me? It gives me a U64, which I think is a number of milliseconds, if I'm not mistaken. If that is the number of milliseconds, then I just say 64 elapsed is this, and printf filling took %lu /n, and then elapsed. And does it build? It does. So let's run prelude spec and see what it says. Why can't I search here? Weird. It took. So I think it's actually microseconds, not milliseconds. So I think it's like 30 milliseconds because it definitely didn't take 30 seconds, right? So I think it's 30 milliseconds. So let's do like this and say milliseconds. And I can do build.bat. Right. Divide by 1000. Okay, so it is 30 milliseconds. And now that means that I can try the other version. And the other version is going to be this void star to commit or commit pointer. It is buffer memory plus buffer committed. And then I actually need to do that here. 64 commit size is required to commit minus committed. think that should be what we want, but I don't know. We can try. So that basically takes the same amount of time. Um, I don't know. Do I want to like make it 10 megabytes so it is a bit more visible maybe? 287 milliseconds. I will copy paste this. Okay, so this version is slightly slower, and I assume the larger the buffer is going to be, the slower this is gonna get. So, well, it's only 2 more lines of code, and it is a bit faster. Then why not keep the faster version? Okay, and that looks good. We can clean up the size. I can remove slightly the size here so the tests run faster. We don't need performance counters anymore. Everything is great. Right? Right. Eat and let's close the Visual Studio. No, don't save. Let's rerun the tests. Okay, that seems good. Okay. Add virtual memory buffer that can reserve large memory, large linear memory ranges. In 64-bit operating systems that allows to easily create buffers with stable address that can size up to terabytes of up to terabytes. Yep, that's good. And now this does not actually work on Linux because of these virtual alloc and virtual free calls. I can try to quickly make it work on Linux, but if I will not be able to, then I will just wrap this up and spend some more time researching, because again, I'm not very familiar with Linux syscalls. Okay, so we have map and we have unmap. Fine, so unmap is probably pretty straightforward, and this is exactly what we need to do here. But with mapping, that's a bit more complicated. So if we are in Win32, then it is that. Otherwise, we do this, right? Protection read, protection write sounds great. Map private, map anonymous sounds also great. Honestly, we can move these in. Fine. Let them be as they are. So we want anonymous and at offsets 0. That's perfectly fine. The problem is, I think if I'm gonna ask for a lot of memory on Linux, it's not gonna be very happy with me. I don't think. But I'm not even sure how to test that correctly. So let's try to Google a bit. So we'll say mmap reserve no commit. We reserve virtual memory. So there is some area here. Map no reserve. No reserve. Do not reserve swap space for this mapping. When swap space is reserved, one has the guarantee that it's possible to modify the mapping. When swap space is not reserved, you can get 6 seg when write if no physical memory available. Okay, that might be what I want to get. The question is, can I afterwards do something about that? Protect. What about advice? What are you going to tell me? Default, will need, do not need. Support, poison, mergeable, unmergeable, huge page. Free. Yeah, that's not what I exactly want. I also want to have a map. Map creates a new mapping. So I ended up in the same thing as unmap. Deletes mappings was a specified address range and causes further references generated in value memory. The region is also automatically unmapped when the process is terminated. It's very unclear to me. So we can try to make it like this. Map no reserve, and then we will try to call it with reserve, but the problem is address is this thing. I don't think that this call will succeed. So like equivalent of this call, more or less, will succeed. No idea. Maybe I need to have some other combination of functions that a bit more funky. I don't know. We'll see. It might be that I don't need to particularly even do anything. I think I don't even need to do anything here. Let's just try to make it like this. Unmap. Did I screw this up? Ah, right, that's the other way around. Duh. Okay, so the question is, does it work in Linux? cd dev library c and build.sh. Right, size in bytes. That's not what I want. I want capacity. I might also need to cut this variable. No, okay. So that builds just fine. But does it blend? Let's see. Apparently there is no such file. Fine. Prelude. So build prelude spec. Well, it doesn't crash. And that is very, very nice to hear. What if we try to... How can I test this? Well, let's try to, for now, just create a very large capacity, but don't fill it in completely. So this will create a gig of memory, but will not actually write to the whole gig, which might be a better test for both of them, to be honest. And I will not even create a gigabyte of memory. I will create a terabyte of memory. So capacity, and then this would be used. So we'll create capacity, but here we only will iterate over the used portion of it. Overflow in type int, no good. Not sure if I need to put it in all of them, but don't hurt. Okay. Seems just fine. At least it doesn't crash. It seems to do what we want to do. I can rerun the tests on the, actually here. And that would be, yeah, everything seems to work. I call it very much a success. Let's commit this, and that would be all for today, I think. Support virtual memory buffer on Linux. Great. If you made it this far, then thank you very much for watching. Hopefully you have learned something new. I know I did. And with that, goodbye.